Yes, hello. Is this audible? Yes, Atif, are you able to hear me?
Yes, teacher.
Alright. So in the last class, we had started with electric field lines and we had covered most of its properties, some of its properties. So the first one included that the tangent to the electric field line gives us the direction of electric field. Then we had seen the closer the lines are, it gives it strength more. And the farther away the lines are, it means that the electric field strength is weaker. Then for a positive charge, electric field lines are directed away from the charge, and for negative charge, all the field lines are directed towards the charge. And these are continuous curves. Electric field lines emerge from the negative charge and emerge from the positive and terminate at the negative one. Then the point where no electric field crosses. This means this is the neutral point. Now see one more thing in this. See, if there are two unequal charges present, unequal, let's say positive charges present. So see, if Q1 is there, Q2 is there, and these are unequal charges, means the both of them will have different magnitudes. So let's say Q2 has greater magnitude than Q1. Then you see the neutral point will lie towards Q1. So neutral point lies towards the charge which has the lesser magnitude. So if this is the charge Q1, this is the charge Q2. The field lines are directed away for charge Q1. Similarly, for Q2 also, field lines will be directed away from Q2. So, field lines will be directed away. For this. Now see, the neutral point lies to the point that is near the charge with the smaller magnitude. So since Q1 has lesser magnitude, neutral point will lie somewhere here. That's why we'll see this kind of thing. Had Q2's magnitude been greater than Q1, then reverse would have happened. Here we would have had Q2, here we would have had Q1. So here is how the neutral point lies whenever two unequal charges are present. Rest of the properties we have already discussed. One more thing regarding uniform electric field, we have not discussed what is meant by uniform electric field. So for uniform electric field, both the magnitude and the direction of electric field of electric field, this does not change. This remains constant. If the direction of electric field is the same and the magnitude is also same, we say we have a uniform electric field. Both magnitude and direction of field does not, both of them remain constant. Remain constant. Then we say remain constant means what? Remain constant means that do not change with position. If you remember in class 11th, you have done uniform velocity. So what does uniform velocity means? Uniform velocity basically means covering equal distances in equal intervals of time. That is what is meant by uniform electric field as well. If the magnitude of electric field is not changing and the direction is also not changing. So we say we have uniform electric field. So now see, if we have to represent this uniform electric field, we'll be having straight lines with constant distance. These are parallel lines. So regarding electric field lines, whenever you have to represent a uniform electric field, you can represent it through parallel lines and equidistant field lines. Equidistant field lines. This is how you represent a uniform electric field. Uniform electric field basically means like at this point, if this is a uniform electric field, then at this point also the field, let's say, is 10 Newton per coulomb. Then at this point also electric field will be 10 Newton per coulombs only. At this point also electric field will be 10 Newton per coulombs only. So this was left in your part which we were doing on Wednesday, uniform electric field line. And if you are given two unequal charges, where will you place neutral point? So neutral point will lie to the charge which has lesser magnitude. So just copy it down. Many of you have entered late. Hania, Memuna, Sara, what happened? Okay, okay, Sara. No issues. Okay, okay, Memuna. No problem. All right, Hania. Sara, did you see the previous recordings which you missed? The initial lectures which we had covered? Okay, okay. Just take the link and start watching them whenever you get time. Yes, written? Done? Are you all done with this? Oh. Yes, ma'am. Muna, have you written? Okay, so this was regarding electric field lines, which we had in your syllabus. Now, see, the next topic that you have is charged particle in an electric field. So, half of the part this you already know in the starting when we discussed electric field. When we discussed electric field, we had seen a relationship between force, charge, and electric field. Does anyone of you remember it? What was the relationship between electric field, force, and charge? Yes, anyone? Any relationship between force, electric field, and charge?
Electric field is defined as the force experienced by unit charge.
Force experienced by unit charge. So the formula is electric field is force upon charge. No. So from here you can say force will be what? Charge multiplied by electric field. So this relation you are already aware of, but just how to utilize this relation we'll see. If you have uniform electric field, so uniform electric field is represented in this way only, parallel and equidistant lines. Now see, these are parallel equidistant lines. If I say I have a charge over here, if I say this is plus Q charge present and it is experiencing a force, and this is the electric field. These are the electric field lines. So I'll simply say the whatever force on this charge will be equal to product of the charge magnitude and the electric field. This is the relation that we have. So see, E electric field, this is uniform over here and the magnitude of charge will be same. So now see, Q's magnitude is same, electric field is constant, so force will also, we will also get a constant. So this will be force on plus Q charge, a positive charge I have taken. So this is just a case for positive charge. So force on plus Q charge due to electric field E. Electric field E. So force on charge plus Q due to electric field will be this. Now see, for a positive charge, how do you take the direction? For a positive charge, if you have to relate the force's direction, so direction of force will be the same of electric field. I'll write down here also. So direction of force, this will be direction of force. This is same as that of electric field. Electric field. So if I say electric field is directed in this side towards the right hand side, so the direction of force on this plus Q charge will also be in the right hand side also. This is valid for only a positive charge. Now see, if we take a negative charge instead of this positive charge, if I take a negative charge, if I take a negative charge, in this similar case, this is uniform electric field whose direction is towards the right hand side. Now see, I have taken minus Q charge now. Now it is not plus Q, now it is minus Q charge. So electric field is directed where? Electric field is directed towards the right hand side. So the force acting on this negative charge will be towards the left hand side in the opposite direction. So electric field force due to electric field will be in this direction, just opposite to whatever is the direction of electric field. But the magnitude will be the same. This will be minus q into electric field, whatever is the charge you have. See, force is a vector quantity, it can be negative, so you can take the charge as minus q into electric field if you are using it in vector form. When you are writing the magnitude, take the magnitude only. And the direction of force, this will be opposite to that of electric field. So just do one thing, it's a start time over here. Just copy this part down till the time I'm coming. I'll take a 10 minutes break.
Okay, teacher.
Yes, have you all written till here? Now see how to use these two formulas that we have done. One formula only for plus q, you can write it as plus q, and for minus q, you can write it as minus q. But whenever you are asked the magnitude, you have to use only QE. Now see, if I give you a question, if all of you have written, I'm scrolling it down. See a charged particle of plus 2 coulomb. This is placed in electric field of 5 Newton per coulomb. As shown, I'll draw the figure also. We have to calculate the force. So see, for the first part, if I give you electric lines as this, these are the electric field lines. So this uniformity simply shows you that this is a uniform electric field line because both of these lines are parallel and equidistant. Now see, we have to find out the force. So the charge is plus 2 coulomb. This is the direction of electric field. Electric field is directed upwards. Now see, I have to first calculate the magnitude because when it says calculate the force, force is a vector quantity. So you should already know that whenever you are submitting your answer, it has to have the direction as well as the magnitude. So regarding the magnitude, electric field is what? 5 Newton per coulomb. Charge is what? Plus 2 coulomb. So what will be the force? Field is given, charge is given. Yes. Magnitude.
Newton.
10 Newton. No. F is equal to Q multiplied by E. Q is 2, E is 5, so you get the magnitude as 10 Newton. But see, submitting your answer as 10 Newton is not sufficient because it's a vector quantity and it has its direction. So since it is a positive charge, what did I tell you? For a positive charge, the direction of force is in the direction of electric field. Whatever is the direction of electric field, that will be the direction of electric force. So if the electric field is directed upwards means which unit vector? I cap, J cap, K cap, minus I cap, minus J cap, which one?
J cap.
J cap, it will be J cap. J cap means in the upwards direction, y-axis. Positive y-axis is J cap. So force will be also directed in this direction. So your complete answer will be 10 J cap Newton. Now, if I just shift this question for the second part, if I tell you, let's not take plus 2 coulomb. Let me tell you that I have taken minus 2 coulomb with me. So electric field lines are still directed upwards only. The charge that I have taken, this is minus 2 coulombs now. So see, in the magnitude in the calculation of magnitude, F will equal to be QE still. Q is 2, electric field is 5, so force will be 10 Newton again. But now see, since this is a negative charge, remember for a negative charge, the direction of electric field and force, both of these are opposite to each other. So if you have a direction of electric field in the upwards axis, means positive y-axis, means the unit vector J cap. So electric force will be directed in the opposite direction. Opposite direction means downwards. This will be the direction of electric force if the electric field is directed in the J cap. So your answer will be 10 Here it will be minus j cap newtons. So you can write it as minus 10 j cap newton also. Clear? Very simple, easy formula based question. Any doubts? Just note down this. Just note down this. In the second part, Hania,
Yes, ma'am.
see, if you will take it as minus 2 coulombs in the second part, we are calculating the magnitude only. Here we are calculating the magnitude. If we want to put the answer, see, if you will take minus 2 coulombs, what will be the answer? Minus 10 Newton only. Here the direction won't be specified. So we are calculating the magnitude and the direction separately. So that's why we have calculated the magnitude first. And then we have added the direction. So automatically your answer will come out to be negative only. So minus 2 coulomb has been compensated over here. This minus 10 J cap shows that 10 Newton is the magnitude of the force and minus J cap is representing the opposite direction, which signifies that this charge is a negative charge. All right?
Thank you, ma'am.
Okay. Yes, have you completed this question? Written till minus 10 J cap?
Yes.
Okay. Now see this question. A proton and an electron are placed at rest near positive and negative plates. See, what does this mean? This is a plate that I have. It will be having negative charge. This plate is negatively charged. So both the sides of this plate is negatively charged. Negative charge is there on this plate. Similarly, positive charges are here on this plate. Now see, it says calculate time taken by proton and electron to reach the opposite plate. So electron is obviously here because negative charges are residing on this plate, and proton is here because positive charges are residing on this lower plate, bottom plate that is present. Now see, electric field, direction of electric field. We have studied in last class also that electric field lines originate from the positive charge and terminate at the negative charge. It means electric field lines, the direction will be in this manner, means going to the upside. That's what we have seen. No, electric field lines emerge from the positive plate and end at the terminating plate, at the negative plate. Now what is happening? Let us take the separation between these two plates as small t. This is also one of your kind of derivation also. So just mark this question as important because many questions will be based on this only. So this will be a generalized formula kind of question for you where you can derive out various types of other particles also. Like instead of proton or electron, if they are provided you some other elementary particle. Now see, electron is there, proton is here. Means electron is coming downwards to this plate and proton is moving upwards to this negative plate. Both of these are reaching opposite plates, because it is saying us that we have to calculate the time taken by the proton and electron to reach the opposite plates. Now see, force on the proton. This is a positive charge. Proton is a positive charge. So direction of force on proton will be the same as that of electric field. So for electric field is moving upwards. For proton also the force will act over here. And force on proton, if you take the magnitude, how do we write the formula of force? Charge multiplied by electric field. And what is the charge on a proton? I have told you, charge on proton and charge on electron both are same. It's just the difference in their signs. Both of them are equal to E. What is the value of E? Yes, we have studied this in the first class. Value of the small e, electronic charge.
1.6 to the 10 to the power of -9.
Yes, ma'am, correct. 1.6 into 10 to the power minus 19. This is the same electric charge. So that is plus E for a proton and minus E for electron. Then we have electric field as capital E. Now see, let us take the mass of proton as MP. Mass of proton as MP. If you have mass, if you have force, how do you relate it with acceleration? What will be the acceleration on the proton?
F by m.
F by m. F divided by m. This is what is the value of acceleration. Force is equal to ma. So acceleration will be F by m. Now see, force is what? Small e multiplied by capital E. And what is the mass of proton? Mass of proton, we have taken it as small mp. So acceleration, we have it. We have the acceleration now. We have to calculate the time. If you remember all your equations of motion in 1D and motion in 2D, this question is very easy now. Initially, both are at rest. Distance covered by both of them, proton as well as electron. Yes, can any one of you tell me what is the distance that will be covered at the end by any of them?
D.
D. Atif is right. See, proton is moving from this plate to this plate and electron is moving from this plate to this plate. So what is the separation between these two plates? We have assumed it at small d. So this will be, so the distance will be small d. Now, if you remember your equation, S is equal to ut plus half at square. This equation from your motion in 1D, this equation, all of you have done it. Let us put all the values. Instead of S, we have small d. U is 0. U multiplied by 0, this gives U multiplied by T, this is 0. Plus half multiplied by half acceleration. Acceleration you have as E, capital E divided by MP. This is acceleration and then square of time. So time period for proton, this is time period for proton. So from here, time period of proton will be what? 2 MP small d divided by E, capital E, and under root of it. This will be time period for proton. TP means time period for proton only. Time period for proton. This is how you will be calculating. So had it asked you the initial velocity, if it would be having, then you would be using the same equation, S is equal to ut plus half at square. Now see, for electron, this was the case for proton. For the case of electron, few things will be only reversed. Instead of mass of proton, we will be taking mass of electron. Instead of acceleration of proton, we will be taking acceleration of electron. So acceleration of electron here will be EE divided by ME, the way you had it for proton. Now see, rest of the things are same. So again, time period will come out to be 2ME small d divided by E capital E. Everything is same. Where did the difference come? In mass of electron and mass of proton. So see, you have both these values. This was the mass, this was the time period of proton. Now see, 2 is a constant number. Small d is fixed. The distance between the plates will be fixed, no? Electronic charge is constant, whose value you all remember. Electric field is given to you in the question, so that is also constant. Mass of proton and mass of electron. Time period is dependent on mass only. The rest of the things are same for proton and electron. See, just see both of these equations. Look at these two equations. This is time period for proton and this is time period for electron. Now look, 2, both are common. T means the distance is same. Small e means the electronic charge is same. Capital E means the electric field is same for both of them. Just the difference in both of these formulas is coming in the masses. It means time period is dependent on the mass. So if a question is given to you, and not in this question, because in this question it has not been mentioned, if it asks you in such a manner, whose time period is more? So just compare, if mass of proton is greater than mass of electron, then obviously time period of proton will be greater than time period of electron. Is this question clear? Any doubts?
Yes,
Should I repeat?
Ma'am, can you repeat?
Okay, let me just summarize it. See, the question said electrons are present in one plate and protons are present in the other plate. Electron is released and it will move to the other plate. Proton will be released and it will go upwards to the other plate. Opposite plate it is reaching. And it has asked us to calculate the time period of each of them. Means for a proton, whatever is the time period, for electron, whatever is the time period. Now see, let us take first on proton. This is the case for proton. So the force in case of proton, this will be QE. Q means the charge on proton, that is electronic charge, and electric field is capital E. So force will be QE. MP is the mass, so acceleration is force by mass, and we get the acceleration value as EE by MP. Then the distance between both of them is small d. So if you apply this equation, what you get? If you apply this equation, S is equal to ut plus half at square, time period is coming out to be, see, u is 0, this part is 0 because initial velocity is 0. Once you put on all the values, you get time period as under root 2 mp small d divided by E capital E, where mp is the mass of proton, d is distance between both the plates, E is the electronic charge, and capital E is the electric field. If you take the case for electrons, then everything will be same. It's just that instead of having mass of proton, we will be having mass of electron. And if you are asked to compare the time period between the two, between the proton's time period and the electron's time period, then what you do? See, all the things are same for both of them. It means time period is dependent on the mass. And we know mass of proton is greater than the mass of electron. So time period of proton will be greater than time period of electron. This is how you solve these kind of questions. In this, if it asks you the direction of force on electric field, see, electric field on electric field is directed upwards. So force on electron will be in the downwards direction. Now you can easily see why electron is able to move in the downwards place. Why proton is able to move in the upwards plate, because electric field is directed in the upward direction. For proton, the direction of force is the same as that of electric field. Why? Because proton is a positive charge, and we have seen for positive charges, the force is in this direction of electric field. So proton will move upwards, and that's why electron will come downwards. Reason is this only, because force is allowing it to move downwards. Now, is it clear?
Yes, ma'am.
All right, so just note it down, all those who have not written. And if you have any doubts, we'll discuss. Just write done when you all have written. Huzaifa, are you able to understand? Huzaifa Ahmed? All right. Okay, so most of you have completed also. Let's discuss this one more question that I have written. Predict the magnitude and direction of electric field so that Q is in equilibrium. Q is in equilibrium means if you have a mass, a charge over here with mass M, this has charge plus Q and this is a particle that you have. Now see it, the question figure I'll draw. This is the mass that you have and direction of electric field is over here. All right. Now see all the forces that can act on this charge. Let us predict one by one. So yes, who all are there? Hania, you tell me. According to you, do you think any force can occur in this plus Q charge? Is there any force possible? Which force, Hania? Any force that you think is possible in this diagram that has been given you? You have said yes. So which force? Yes, Hania. Okay, anyone else? Yes, Hania. Not electric field. Electric field is not a force. Electric field is force experienced by a charge. So that is different. Electric force you have to write. Electrostatic force that we have been discussing. See, this electric field is not because of this plus Q charge. Remember, whenever you have this kind of situation where electric field is present or whatever we are discussing in today's class, in this what has happened? We have electric field with us and we have placed a charge over here, means in this electric field. So this electric field is of some other charge who has generated its electric field. Now in this electric field, we are keeping another charge and then we are seeing what are the different cases possible. Because obviously I have told you electric field is a phenomenon of a single charge, but electric force is not a phenomenon of a single charge, no. And we are able to see only plus Q charge. So how can we get a force if we have only a single charge? Because mono charges do not lead to electric forces. So the reason is that only this electric field in which we are keeping the charge, this electric field is generated because of some other charge. So don't get confused with this electric field and this charge. So this electric field has been generated by some other charge. So one will be electric force experience, as rightly said by Hania. Now see, this is a positive charge. Electric field is directed upwards. As I've told you, electric field, the direction for force on a positive charge is same as that of electric field. So if electric field is directed upwards, for a positive charge, electric force will also be directed upwards. If this is at a certain distance from Earth, can any one of you tell me, is there any other force possible now, apart from this electric force?
Can you repeat what you asked?
Atif, I have said that electric force we have considered. This is one of the forces. If this mass is at a certain distance from Earth, we have this mass over here. Apart from electric force, can any one of you tell me, is there a possibility of another force? Or this is the only force that will occur?
Gravitational force.
Gravitational force. See, gravitational force will also occur. Yes, Hania, correct. It will be gravitational force. Gravitational force will be directed downwards and its value will be mg. So these are all the forces acting on this charge, whose mass is m, whose charge is plus q. Now see, it is saying in equilibrium. Equilibrium means net force is zero. When can we say net force is zero? When upward forces is balancing the downward forces. So upward forces are balancing the forces which are downwards. So here we have only single force. It means Fe is balancing mg. And what is the value of electric force? We have right now studied that if capital E is the electric field, Q is the charge, then electric force will be equal to Q multiplied by electric field. This is equal to mg. So it says predict the magnitude and direction of electric field. So here it will be electric field's magnitude will be mg divided by small q. And here it is given that it is directed upwards. This is how you will solve this question. So just remember, had it been a negative charge, then the direction of electric field would have been over here in this manner. This would have been a case for a negative charge. All right, so just note down this question as well. So I think you must have written the question that we have done previously. Now see one more question in this topic. Wherever a charge is placed in electric field, then we'll move further. See, right now we were considering the charge in 1D only. This question deals with motion in 2D. So we have to solve x-axis separately and we have to solve y-axis separately. What does it say? Again, you have set of two plates. So one will be negatively charged, other plate is positively charged. So it says a particle Q. This enters a region of electric field, uniform electric field. Again, direction of electric field will be here only, from the positive to the negative. This is your electric field. These are the electric field lines. That's why we have studied electric field lines prior to this topic. Now see a charge, Q charge, this enters the region of electric field with a velocity v. So the velocity of this charge is v. Now you won't be taking the initial velocity as 0. Now it has provided you the velocity. So it has entered the region with a velocity small v. Length of plate is L, means this is L. This length of the plate is L, and similarly the length of negative plate is also L, the length of this positive plate is also L. Now it says to calculate the time taken by the particle to cross the plates. It means the particle will begin. Now see, it is a positively charged particle and the other plate is negatively charged. Now look carefully. Once it will be start moving, what will happen? It will move, and the negative plate will try to attract it, and this will move somewhere like this. If you have this kind of situation, this will be the trajectory. Why? It is a positive charge. It has entered this region of electric field. What will happen? This is a positive charge. This negative plate will attract this. So it will move straight away, but inclination is towards the negative plate. Why there is this slight inclination? Because negative will be attracting this positive. This will be the trajectory. So it has asked us to in the first part, it has asked us to calculate the time for this, and then it has asked a deflection of particle. Deflection of particle means this distance. This. What should have been the initial position, now what is the final position, and the difference between the two. Why will be this is the deflection, because it has deflected its path through this y distance only. So we have to calculate both of these quantities. Now before we begin, let us separately write it for x-axis and y-axis. So let us first discuss motion along x-axis. Okay, so just consider all the motion along x-axis. Don't even consider that it is moving over here. It has covered some distance in y direction also. Just look at the x-axis aspect. So any one of you tell me what is the distance that will be covered? Yes. L, capital L. Very good, Atif. See, if it is moving, then at the x-axis, the distance will be covered L only. So x will be L. Do all of you agree to this? X will be capital L, because this is the distance that is covered in the x-axis. Now let us see force. Force on x-axis. Electric field is directed upwards, means in the y-axis. For a positive charge, force will also be acting in the y-axis. So do we have force in the x-axis? Do we have force in the x-axis? See, all the forces are directed in the y-axis only, because electric field is directed in the y-axis. So it means Fx will be 0. You don't have any force in here. Just look in this diagram also, in this figure also. Are you able to just see any force? Only electric force exists, which is pulling it towards itself. This trajectory is possible because of electric force. So that is directed in y-axis. For x-axis, we don't have any force. So fx will be 0. If fx is 0, then acceleration will also be 0. Force is 0, acceleration will also be 0. All of you write me in the chat box. What is the initial velocity along x-axis? Read the question or just look in the figure. Are you able to see any velocity in the x-axis? Only Hania has answered. Look at the figure. Are you able to see any velocity in the x-axis? Or will ux be equal to 0? See, rest of you, this velocity, this is the velocity. Is it acting along y-axis? No, this is acting along x-axis only. So your ux is equal to small v. All of you tell me, is it clear till here? How have we taken x, fx, ax, ux? If anybody is having doubt, just ask me. I'll repeat it once more. Now see, these are all the values that we have. Now let us take the equation, main equation that we have. S is equal to ut plus half at square. So everything will be with respect to x-axis, ux, ax. Sx means distance. This is L. In ux is equal to small v. Time period, we don't know. We have to calculate the time period. We are already in search of this time period. Let us take this as t plus half. Acceleration is 0 multiplied by t square. So L is equal to small v multiplied by t. So from here you can say time period is equal to length of plate divided by velocity. First part is clear to all of you? Yes, Mamuna, were you saying something? All right. So see, if you put in the values in this, you simply get, because this part will be equal to 0 because acceleration is not there. So L is equal to Vt and T will be equal to L by V. So this was when we have solved it for only x-axis. We have to consider motion along y-axis for the calculation of deflection. Motion along y-axis. This will be the answer for second part. For the first part, we have calculated the time period. Time period can easily be calculated through x-axis, all the data that is available. For y-axis, we are because of deflection has occurred in the y-axis. That's why we are using motion along the y-axis. So y, we have to calculate. We don't know what is this distance. We are actually finding out this. Means this distance. We don't know this distance. So let it be y. Now see force along y-axis. All of you write me in the chat box. Will there be any force along y-axis, or like fx, will fy be equal to 0? Look in the figure. Figure is in front of you. Atif, you are correct. Yes, Hania, you are correct. Memuna, you have written y is equal to f. Distance will not be equal to force. Okay, you're saying along y-axis there will be force. All right. So yes, along y-axis we have the force. In the x-axis, we didn't have any force. Along the y-axis, we have the electric force, which we are studying, which we have studied. If E is the electric force, Q is the charge, then electric force will be equal to Qy. So force along y-axis, this will be equal to small q multiplied by electric field. This is Fy we have. So if we have Fy with us, we will be having Ay also. Acceleration will be force divided by the mass. So charge multiplied by electric field gives you the force divided by mass. This gives you acceleration. So this time we do have the acceleration. Regarding the time period we have calculated from the first part, that is L divided by V. Now Uy will be equal to 0. See, the velocity, initial velocity is directed only in this direction, x-axis. There is no velocity in y direction. It means velocity in y-axis is 0. So we have all the data with us. Now let us put it in the equation. Y is equal to Uyt plus half Ay t square. So Uy, this is 0. Why? Because Uy is 0, so Uy multiplied by t will give you 0. You only have y is equal to half Ay. Ay we have just calculated. Ay is QE divided by M. So Ay will be QE divided by M. This is Ay. T square. T was what? T is L divided by V. So T square will be L divided by V's whole square. This is T square. So Y will be equal to what? QEL square divided by 2MV square. This is the deflection. Clear? Just note down this question as well. If anyone wants me to repeat, just let me know. I'll repeat it once more. Okay, all of you who have written, I have shared a link with you all. So just click on this link and fill in the details whichever is asked, please. Whatever are the details, just complete it once. I think the link is visible. Is the link visible to all of you? Just check it in
Yes,
the
ma'am.
chat box. Okay. So please fill it once you have written. Written till here, y is equal to QEL square by 2mv square.
Yes, ma'am.
All right. So just fill in the Google form or whatever is the document given to you. We will start with torque. So revise the basics of torque, cross product and all that we'll discuss on Wednesday. All right. Okay.
Okay, teacher. Thank you, teacher.
So